Welcome to The Explainer. Today, we're going to talk about a super powerful tool called linear programming. I know, it sounds kind of nerdy, but stick with me. It's all about making the absolute best decision you can when you just can't have it all. A problem we all face, right?
So let's frame this. How do you make that perfect call when what you have to work with is limited? Imagine you're running a company, right? You want to maximize your profit. But the catch is, you don't have unlimited materials or unlimited people to do the work. So what's the best move? This is a classic business puzzle. And, believe it or not, linear programming is basically the treasure map to the solution.
All right, Section 1, a profitable puzzle. We're going to set up the core problem here. And to really see how this works, we're going to dive into a super simple but really powerful example. Let's picture a company that makes just two things. We'll just call them Product X and Product Y. The problem? They're facing a couple of really key shortages.
Okay, so this table right here, it lays out the whole challenge for us. You can see we've got a hard limit on our materials, 15,000 kilograms. That's it. And for labor, we've got 16,000 hours, not a minute more. Now, look at the profit. Product X nets us $30 a pop. Product Y is even better, bringing in $40. So the big question is, what's the perfect mix of X and Y to make?
Okay, next up, mapping the possibilities. We're going to turn our limits into an actual decision map. So, how do we even start to untangle this mess? Well, the great thing is we don't have to guess. Instead, we're going to literally build a visual map of every single production plan that is even possible.
First things first, we need to be crystal clear about our goal. In fancy terms, this is called the objective function. But really, it's just a simple formula for our total profit. We get $30 for every X we sell and $40 for every Y. So our mission, should we choose to accept it, is to make the result of that equation as huge as we possibly can.
And of course, every game has rules. These two equations here, these are our limits, or what we call constraints. The first one is for materials. It's just saying that the total materials we use for both X and Y has to be less than or equal to our 15,000 kilogram limit. And the second one is for labor. Same deal. Total hours can't top 16,000. These two lines in the sand define our entire playground.
So how do we actually draw these boundaries on a map? Well, we figure out the absolute extremes. Let's take the materials rule. What if we put all our materials into making just product Y? We could crank out 3,000 units. Okay, what if we only made product X? We could make 5,000. Boom, that gives us 2 points, and we can draw our first line. Then we do the exact same thing for our labor limit. If we used all 16,000 hours, we could make 4,000 of X or 4,000 of Y.
Okay, so now that we've plotted both of those limit lines on a graph, you see that shaded area, the part that satisfies all of our rules? That's called the feasible region. Think of it like a complete menu of every possible production plan the company can pull off. Any point inside this shape is a go. Anything outside, totally impossible.
All right, next section, finding the sweet spot. Time to identify the single best plan. So, our map shows us like thousands, technically infinite, possible plans. How in the world do we find the one that makes us the most money?
And this, my friends, is where the magic of linear programming comes in. It's so cool. The math proves that the single most profitable point, the absolute best answer, will always be at one of the corners of that feasible region shape. Always. We don't have to check any of the endless points in the middle, just the corners.
And for our specific puzzle, that best, most profitable corner happens to be exactly where our two main limits, the material line and the labor line, cross paths. That's the sweet spot. It's the one point where we're perfectly balancing and maxing out both of our limited resources at the same time. So you do the math to find that exact point of intersection. And what do you get? A perfect, precise answer. The best possible plan is to manufacture exactly 2,500 units of product X and 1,500 units of product Y. No more, no less. So what does that perfect plan actually get us? Well, when you plug those numbers back into our original profit equation, you get the maximum possible profit, $135,000. That's the ceiling. It's literally impossible to make more money than that with the resources we have. But wait, there's more. Finding the best plan is awesome, but that's really only half the story. Linear programming has another trick up its sleeve. It can show us something really deep, the true value of our limited resources. We're about to calculate the real price of scarcity.
So let's ask a really strategic question. Let's say you could get your hands on just 1 more kilogram of material. What's that really worth to your business? How much should you be willing to pay for it? Is it worth its normal price, or is there some hidden extra value?
The answer to that question has a fantastic name. It's called the shadow price. Think of it as the hidden value of getting just 1 more unit of something you're short on. It tells you exactly how much your total profit would jump up if you could just get 1 more kilogram of material or 1 more hour of labor.
And in our example, it's pretty amazing. If you rerun the whole calculation, but this time you have 15,001 kilograms of material instead of 15,000, your max profit goes from $135,000 up to $135,005. That extra $5, that is the shadow price for 1 kilogram of material.
And this is what makes it so powerful. It gives managers a dead simple, crystal clear rule for making decisions. Let's say the normal price for our material is $8 a kilo. Well, you add that $5 shadow price, and now you know you should be willing to pay up to $13 for an extra kilogram. Pay less than $13, that's a smart buy, you're going to make more profit. Pay more than $13, that's a bad deal. You're actually losing money.
Okay, last section. When numbers aren't enough. Because we've got to ask the big, final question, right? Is the mathematically perfect answer always the right call in the real world? The model gives us an amazing target. But as we all know, reality is always a little messier.
Look, a graph is a fantastic tool, but the real world is way more complex. This model is an unbelievably powerful guide, for sure, but it can't see the whole picture. Your job as the decision maker is to take this perfect number-based answer and weigh it against all the human stuff, the factors that you just can't plug into an equation.
Like what? Well, for example, maybe you should pay more than that $13 cutoff for extra materials because it means keeping a hugely important long-term customer happy. Or maybe you have to do it to avoid a massive penalty for breaking a contract. And what about things like the quality of those extra materials? Or how reliable is that new supplier? The math can't tell you any of that.
And you know, this way of thinking isn't just for factory floors. This is a framework for any big decision you have to make where your resources, your time, your money, your energy are finite. So the next time you're facing a really tough choice, I want you to ask yourself this: what are my real limits here? And what's the hidden value? What's the shadow price of finding a way to push just a little bit past them?